Okay, so in this example, a bank offers a special savings account with 4.2% APR. The man deposits €250 at the start of each month for a 2-year period. How much will his investment be worth at the end of 2 years? Now, to turn a yearly AER into a monthly AER, what you got to remember is at the end of 1 year, you're going to have 104.2% or 1.042 at the end of the year. This has to be the same as compounding by 12 months. Okay, so what we're going to get is we have to find out what 1 plus I is on its own. So this will be the monthly rate, so to speak. So 1 plus I equals the 12th root of 1.042. So what we do here is we put in the 12th root, which is here, of 1.042. And what we get is 1.00343. Now we press Shift star B. What we did is we saved this as the variable B. Okay. Now the next equation we're going to use is F. F equals P into 1 plus I times T. Okay. Now we're doing the start of each month for a 2-year period. 2-year period equals 24 months. Okay. So 24 months. Now, the final payment, right, so the total, okay, the very last payment is going to be made on December. And it's going to be there for 1 month, the start of December to the end of December. So the very last payment is going to be €250 multiplied by B. Now this 250 by B shows you that it accumulates 1 month's worth of interest. So this accumulates 85 cents. Okay. The second last payment is going to be in there for 2 months. So B to the power 2. And this, like the previous example, will accumulate. This €250 is going to accumulate 2 months worth of AER, which is going to be 251.72. Now we're going to go all the way to the end, where we're going to have €250. Now this is the very first one we put in, and the very first one we put in is there for 24 months. So it's going to be B to the power 24. So we have to find out is what is the cost of all this investment added together. So we can see that's a geometric series. So we're going to see Sn equals 1 minus R to the n all over 1 minus R. Now, our R value, or our A value, is 250B. Our R value, as you can see, it goes up by B each time. Okay? And now we've got to find out what Sn is. So, Sn is going to equal 250 into 1 minus 1 minus B. Now there's 24 terms, 24 installments, so it's going to be B to the power 24 all over 1 minus B. So put this into the calculator, press the fraction button at the start, 250B into 1 minus B24. Close the bracket, all over 1 minus B. And what we get here is 6,264.49, I mean. So 2,264.49. Okay, so that's the answer to the first question. Now, moving on to the next question, which is question 3. A credit union offers a savings account with EAR of 3.6%. Same thing as AER. A man deposits €175 at the end. Now, the end of each month is significant. Starting on the 31st of January. How much will this investment be worth on December 2012? So look, I'm going to count out the amount of years. 08 to 09, 09 to 10, 10 to 11, 11 to 12, and then 12 to 13. So that's going to be 1, 2, 3, 4. That's 5 years or 60 months. Okay, so this here is 60 months. Now, what we're going to do next is we're going to use our F equals P into 1 plus I times T. Now the thing is, we have a yearly AER, okay, so this 1 plus I, because we're doing it in monthly installments, 1 plus I to the power 12 has to be the equivalent of a yearly increase. And we're going to start this as our variable b. Our variable b therefore equals the 12th root of 1.036. So what we get here is the 12th root of 1.036, and what we get there is 1.00295. Okay, so we're going to shift, star, and star this as b. Okay, now we're going to set up our final amount. Now remember, we're investing each month. Okay, so our very last payment is going to be made at the very last day. It's going to have no time to accumulate money. So this is going to be 175. Our payment before that has 1 month to accumulate interest. The payment before that has 2 months to accumulate interest. Then we're going to go all the way to the first payment we made. The first payment we made was 1 month in, was at the end of the first month. This means it has 59 months to accumulate interest. Okay, so 59 months to accumulate interest. Once again, this is a geometric series with a into 1 minus rn all over 1 minus r. Our a value is 175, our n value is 60, and our r value equals b. So we're just going to put that into the calculator exactly as it looks now on the board. All over 1 minus b. Now, so what we get is Sn equals, so 175 into 1 minus b to the power 60, all divided by 1 minus b. And what we get here is 11,468.70. So 11,468.70, and that's our final, that's our amount, our full amount. That's how much investment will be worth at the end of the couple of years. Okay. Now, the company plans to issue an 8-year 2,500 bond that will pay €1,150 at the end of every year, based on an interest rate of 4% per annum. What is a fair market value for this bond? Well, the thing to remember is that future money is worth less now. So for example, the future money of 2,500, so 2,500 in the future, we have to figure out what is its present value, P, under the conditions of 1.04, because you're adding on 4% to the power of 8. So we have to find out what is the present value of this, which is going to be 2,500 divided by 1.04 to the power of 8. So it's going to be 2,500 divided by 1.04. That's all going to be to the power of 8. And what we get is 1,826.73. So 1,826.73. And once we've completed that, the next problem is in the next problem is based on basically based on the amount we're putting in at the end of each year. Now once again, we're going to use the same formula. Okay, so if we receive €150 at the end of a year, okay, so P equals F over 1 plus I to the power of T. Now remember, our present value equals the future value, which is 150. It's going to be 1.04. And the t value is the number of years in the future I receive it in. So for example, in 1 year's time, it'd be 150 divided by 1.04. So that means in 1 year's time, if I was to give you €150 in 1 year's time, that would be the same as receiving 144.23 now. Or if I was to give you €150 in 2 years' time, I replace t equals 2. €150 in 2 years' time is the same thing as €138.68 today. So we're trying to find out our present value of this bond. So our present value of this bond works out like this. We're going to do this sequence for basically eight years. Okay, so it's going to be 1.04 to the power 2 plus 150 over 1.04 to the power 3 plus 150 by 1.04 to the power of 8. Now guys, this is a geometric sequence. Sn equals A into 1 minus Rn all over 1 minus R. Our A value is 150 divided by 1.04. Our B value, or our R value, is going to be 1 over 1.04. And we're going to save that as our B value, okay? So B is 1 divided by 1.04. Gonna shift star B. So it's saved as B, okay? So now we're going to do this as a Sn function. Now our n is going to be equal to 8 because we do it for 8 years. So what we're going to get is 150 over 1.04, 1 minus b to the power of 8 all over 1 minus b. So we're going to put that into the calculator. And then we're going to get 150 divided by 1.04. Then we're going to get 1 minus b to the power of 8. And then it's going to be all over 1 minus b. Then press equals and we get 1009.91. 1009.91. And that's not our complete answer. That's the current value of all the 150 euros. But we also have to get the current value of the 2,500 we're going to receive at the end of the year, which is 1,826.73. So 1826.73. So this is what this investment is worth currently. And when we add them together, we should get 2,836.64. Now, in the next question, at the end of each quarter, a deposit of 280 euros made in the account that pays EAR of 5.5%. What will the final amount be after 4 years? Now guys, what we're looking at here is, usually we do it monthly, okay, and we say 1 plus I to the power 12. Now the reason why we do this power 12 is there's going to be 12 payments in the year, and that has to be the equivalent of 1 year's worth of interest. But in this question here, we're no longer using the 12, we're using 4. We only have 4 payments at the end of each quarter. Okay, so it's the 4 payments, so it's basically end of so we have 4 payments, okay. Now, these 4 payments, okay, we're going to have to figure out our B value. Our B value is going to be 1 plus I, and that's going to be equal to the 4th root of 1.055. 4th root of 1.055, and then we're going to get 1.134. Right, we're going to shift star that as B, okay, and then we're going to move on now with what we're doing here, okay. So our F value is equal to our investment 280. Now please remember that the last one is made at the end of the quarter. So this 280 euro is made on December of the last year, the end of December on the last year. It has no time to accumulate money. The one before that is 280 b to the power 1. Now b to the power 1 in this case stands for quarterly. It technically means 3 months because we're using a quarterly interest rate, okay. So that means it's in there for 3 months. The third last payment is in there for 6 months, but once again we're going to use b to the power 2 because it's quarterly rate. Now 4 years multiplied by 4 quarters a year is 16 technically payments, okay, but the last payment was made at the end of the first 3 months, so it's not going to be in there for 16 quarters, it's going to be in there for 15 quarters, so it's going to be 280 by b to the power 15. Now, Sn equals A into 1 minus Rn all over 1 minus r. So what we're going to get is our A value is 280. Our R value is not 15, it's 16, because if you count everything here, there's going to be 16 payments. So it's going to be B to the power 16 all over 1 minus B. Put that into the calculator, and we get 280 multiplied by 1 minus B to the power 16 all over 1 minus B. And what we get is 4,962.53. 4,962.53. Okay. Next question is question 8. Kasim needs €5,000 in 3 years, and he deposits at the end of each month into the account that pays AER 4.8. So 3 years is 36 months, okay? Now how does he achieve this goal? Well, we're going to do it by monthly rates. So 1 plus I to the power 12 equals your yearly rate, 1.048. Our B value is then 1 plus I on its own, which is going to be the 12th root of 1.048. So the 12th root (1.048) is going to be 1.0039 shift star B. Now, if we write down what our final amount is, now we don't know how much we put in each month, so it's going to be X, okay, amount at the end of each month. Now, it says the end of each month, so at the end of December 31st, this amount has no time to accumulate any money, so it's just going to remain as current value. The value before that will have 1 month to accumulate interest. The value before that will have 2 months, all the way up to the first installment we made, which will be there. We put it at the end of January. Okay, our very first installment was made at the end of January, which means it has 35 months to accumulate interest. Okay. Now we know we're going to use a geometric sequence, so it's going to be A into 1 minus Rn all over 1 minus R. And we're going to get is going to be X times 1 minus B. Now remember, it's 36 different installments, so B to the power 36 all over 1 minus B. We're going to put this part here directly into the calculator and see what we get out. So what we get is 1 minus alpha B to the power 36 all over 1 minus B. And what I get here is 38.58. Now 38.58 X equals the final amount, which is 5,000. So we're going to do 5,000 divided by this answer. And what we get is X equals €129.60. Okay, so €129.60. So that's our monthly repayment.